Greetings everyone, and welcome to our third lesson in our first unit in Regents Chemistry. Today we're going to be learning about dimensional analysis. And you might have some experience with this from math classes or potentially even from a couple of your other science classes, depending what you got into with that. But today you'll be able to convert numbers using this process we call dimensional analysis. So to kind of start and give you a little background about what it is, and kind of how we're going to use it in this course, it's a process that we use to convert between different metric units. And that's how we're going to focus on this in Regents Chemistry. We'll mostly use dimensional analysis and conversions to convert between different metric units. If you go beyond Regents Chemistry and decide to take physics or another advanced science course like AP Chemistry, you will use dimensional analysis much more than we will use it in this class. And this process is nice because it cancels other units and leaves us with the desired unit that we're trying to convert into. And this happens as long as we set this up appropriately. In order to set it up appropriately, we need to have a conversion factor. And the conversion factor is really a ratio, a fraction that's going to relate the two units, the one that we start with and the one that we're trying to convert to. This is going to take a simple form. We want to make sure that we put the smaller unit, depending on whether that's the one that we have or the one we're converting to, we want to put the smaller unit on top and compare it to the larger unit on bottom. And because this is the metric system, all of our prefixes are going to change or are based off of a factor of 10. So I have a couple examples here of how we can make a conversion factor. So the first one is going to relate two different metric prefixes, meter and kilometer. Now for this lesson, I would make sure that you have table C on your reference tables out so you can refer to this. And I'm going to give you a little important piece of information. Under where it says factors or factor, it's a column there that says factor. And we have a factor of 10 to the minus 1. That's the second one down. I'm going to change this. Let's call this 10 to the third. Now let me clean this up. It'll probably bother me more than it'll bother most of you, but we'll clean that up. So kilos on the top is 10 to the third, and right beneath that is deci at 10 to the minus 1. At this point right here, in between these two prefixes are what we have, what we call base units. For example, this could be a meter, it could be a gram, it could be a liter. But what I'd like you to write down, and you can put this right in your reference table, is that the factor here for our base units, which are not listed, are times 10 to the 0. And that looks like times 10 to the 16. So I'm going to fix that. And you guys will probably find this is a little bit worse when we're doing class virtually here. But in general, my handwriting is not the greatest, and even harder writing on a screen. So if you have any trouble reading this, ask a friend or ask me, and I will clarify that for you. So all of our base units, which would not have a prefix on it, are going to have a factor of times 10 to the 0. Okay? Now to make a conversion factor, in this case we're going to make a conversion factor that'll help us convert between meters and kilometers. We put the smaller unit on the top. And we tell which one's smaller based off of the power of 10 in the factor, or in the prefix. So kilo or kilometer has a factor of 10 to the third. And a meter, which is a base unit, there's no prefix in front of a meter. There is a prefix in front of kilometer, kilometer. So since we have no prefix in front of meter, that's a base unit, and the factor would therefore be 10 to the 0. Now, the way we can make the conversion factor is by comparing our powers of 10 between the two units. In this case, we have 3 powers of 10 difference, and we're just kind of counting that like we would on a number line. 0 to 3, 1, 2, that would be 3 powers of 10 difference. So our conversion factor, since we're dealing with the metric system, we're always going to start with a 1, and because we have 3 powers of 10 difference, we add 3 zeros, and therefore we have 3 of our smaller unit, meters. Jumping ahead to the one beneath here. We have 1,000 meters per every 1 kilometer. And that would be our conversion factor. And I'll show you how we'll use that in a minute. The next example is relating millimeters to centimeters. So we look up what our factor is, our power of 10, and we compare. Since they're different on a scale of 1 power of 10, we add 1 0 to our conversion factor, and therefore we get 10 millimeters for every 1 centimeter. Your conversion factors in the metric system, when we're converting between metric units, are always going to start with a 1, and then we'll add a certain number of zeros depending on the difference in our power of 10. Now, once you get the conversion factor, we're going to have to follow a couple rules in order to convert our number. And that involves us comparing the number that we're trying to convert, in this case, 100 point meters, and then we compare it to our conversion factor. And are the meters matching in the numerator or in the denominator? In this case, they're matching in the numerator. So when they're matching in the numerator, we're going to want to divide the number that we're converting from by the conversion factor. So in this case, we'll divide 100 by 1,000. This will allow us to cancel our meters, and this is the beauty of dimensional analysis, is getting our units to cancel nice and neat. We're left with the unit of kilometer. So 100 divided by 1,000 is 0.1, and we end up with that unit of kilometers. If the given unit and the number that we're converting matches in the denominator of our conversion factor, in this case our conversion factor is 10 millimeters for every 1 centimeter, then we're going to multiply by the conversion factor in order to get our units to cancel. So if we multiply 100 centimeters by 10 millimeters over 1 centimeter, a centimeter over a centimeter is 1, so those will cancel. We're left with millimeters, which is what our answer is going to be in. So 100 times 10 is 1,000. Our centimeters are canceled, and we're left with millimeters. The number of significant figures in our final answer has to equal the number of sig figs in the number we're converting. So in this case, 100 point would be 3 significant figures, and 1,000 as it's written is only 1 significant figure. So we're either going to want to say that this is going to be 1,000 millimeters, or times 10 to the third millimeters, where we have 1.00, which would be our 3 significant figures. Now let's practice this a little bit. And I'm going to show you an alternate way after this, and I'll let you guys decide which one you want to use. Both will work for this course. Dimensional analysis is the one that you'll want to get comfortable with if you're going to be taking courses in math or science beyond Regents chemistry. So to start, how many millimeters are in 10 decimeters? Now for all of these, make sure you're using table C in your reference tables, and that you can find your prefixes and your factors. Okay. Now we want to convert 10 decimeters into millimeters. So to start, we need to make a conversion factor. Now we'll compare a dm, a decimeter, to a millimeter. And a decimeter has a factor of 10 to the minus 1, and milli has a factor of 10 to the minus 3. Now this is a difference of 2 powers of 10, which means our conversion factor, which would hold, or we'd start with a 1, we're going to have to add in 2 zeros. The smaller unit goes on top, and the larger unit on the bottom. So there are 100 millimeters for every 1 decimeter. This is now our conversion factor. Okay? So we are going to put this next to the number that we're converting and then compare. Now our units of dm and dm match in the denominator. So in this case, in order to get our dm's to cancel and end up with our millimeter units, which is what we want according to the question, we are going to multiply, because they match in the denominator. 10 times 100 would get us 1,000. Decimeters will cancel, and we're left with millimeters. So in 10 decimeters, there are 1,000 millimeters. 100 millimeters for every 1 decimeter. Now we'll do the same process for number 2 here. Convert 100.0 kilometers, km, into centimeters. So we want to take 100.0 kilometers and convert this into centimeters, and that's our target unit. Okay. Now kilometer has a factor of 10 to the third, and centimeter, or centi, has a factor of 10 to the minus 2. This is, excuse me, not 2, but 5 powers of 10 different. So our conversion factor, again, will always start with a 1, and in this case, it's going to be followed by 5 zeros. Now the smaller unit is the centimeter. So there are 100,000 centimeters in 1 kilometer. Now we want to convert 100.0 kilometers, and with each of these numbers, start to practice a little more and more how many sig figs might be in a particular number. So 100.0, again, anytime here you can feel free to pause the video and try and answer some of these questions. So I'll give you a second to think about this. You can pause the video and try and answer this. 100.0 has 4 significant figures. The decimal is going to make the zeros at the end significant, or any zeros after that first non-zero digit, the 1. Now when we compare these two, we have 100 kilometers, and there are 100,000 centimeters per kilometer. Our units are going to match again here in the denominator. When they match in the denominator, we are going to want to multiply. So we get 100 times 100,000, which is going to give us 10 million centimeters. Or, since we want 4 significant figures, I'm going to call this, that would give us 4 significant figures right there, times 10 to the 7th power, and that would be centimeters. So converting 100.0 kilometers into centimeters, we get 1.000 times 10 to the 7th centimeters. Now I also, and you'll see me use this in class occasionally, we'll use an alternate method for conversions, and I like to call this the ratio method. And this will be more used for, it can be used for metric conversions, but I like it for non-metric conversions as well. And this method also is going to require you to develop or come up with a conversion factor that's going to relate the quantity that we have and the quantity that we want. Okay? For example, 1 mile is equal to 1.6 kilometers. Okay? So for every 1 mile, we have 1.6 kilometers. And that's a conversion factor as is. Now with this method, we want to set up a ratio, cross multiply, and solve. And as long as we make sure that our units in the numerator match and the new units in the denominator match, then our answer will have the desired units. For example, if we wanted to figure out how many miles are in 5 kilometers, as long as we know this conversion factor, for every mile there's 1.6 kilometers, we can take this information, and it's almost like setting up an equal conversion factor. We want to know how many miles. We're going to call that x miles are in 5 kilometers. Okay, so we have a conversion factor on the right, and we have the number that we're trying to convert on the left. Our units of miles match in the numerator, our units of kilometers match in the denominator. This has to be true in order for this to work. Now we can just cross multiply. We get 1.6 x is equal to 5. And we get an x value, or x miles, which will be equal to 3.125. We'll convert our final number into significant figures. We had a number here of 5 kilometers. Sometimes these work well, sometimes they don't. And we divided here, or multiplied, same rule. So therefore, this is going to round to one significant figure, which would be 3. And that would be 3 miles. Don't be concerned, as long as you're showing your work. Sometimes when we round numbers due to significant figures, your answer doesn't look as precise as it used to, and that's fine, as long as you're not completely changing what the number is. Now, so we can get another idea of a non-metric conversion using dimensional analysis. I will show you how we'll use dimensional analysis to solve this problem. Now, if we're traveling at a speed of 30 miles an hour, how long is it going to take me to travel 10 miles? Well, we know that we want to travel 10 miles. And we're trying to figure out how long it's going to take us to go at that rate. So we're looking for how long, which is a time. Okay? Now, we're given a conversion factor of 30 miles per hour. And you look at that, it's like, well, that's not a conversion factor. Well, it is. It's miles. It's 30 miles for every 1 hour. And this, we can look at this a couple ways. This could be 30 miles for every 1 hour. Or it could be 1 hour for every 30 miles. And I'm going to choose this one. Because when I use dimensional analysis, I don't like to divide, I just want to multiply. And if I set up the conversion factor in this way, I'm always going to cancel my units that are in the denominator. In this case would be miles. Okay? So if I have 10 miles times 1 hour every 30 miles, what we're going to get here when we multiply this, our miles are going to cancel, and we're going to be left with 10 over 30 hours, which is equal to 1/3 hour, which no one really talks like that. So if I wanted to figure out what 1/3 hour was, I'm going to show you how we can use dimensional analysis to evaluate this further. To travel 10 miles at 1 hour every 30 miles, if I asked you how many minutes that was, instead of 1/3 hour, we could say, well, there are 60 minutes in 1 hour. Well, and you're probably thinking, well, couldn't you say in 1 hour there's 60 minutes and do it the reverse way? You can. But if we multiply straight across, the units that we're trying to get rid of, we need one in the numerator, one in the denominator. So miles cancel with miles, and in this case, hours in the numerator will cancel with hours in the denominator. So when we multiply straight across, we get something like 600 over 30, which is equal to 20, and we left with minutes, would be 20 minutes. And this is the beauty of dimensional analysis. It doesn't have to be used with metric units. It can be used with standard units. It can go between, as long as we have a conversion factor that's going to relate to particular quantities. And sometimes this will take one step. Sometimes this will take many steps. Now you can use this technique as well in this course. It's kind of whatever you're comfortable with. But if you're planning to take a course beyond Regents Chemistry, you'll want to focus on using more of the dimensional analysis method as opposed to the ratio method. If you guys have questions, make sure you write them down. Make sure you ask them during office hours. And when you come across questions on your problem set, you can write those down and ask those during office hours as well. Hope you guys have a great day.